Hello students, in this session we are going to discuss about these topics: inertia, momentum and laws of motion for your B form physics. So the first topic is inertia, and in this topic we shall discuss about definition of inertia, then different types of inertia, and conceptual questions which are asked related with inertia, factors of inertia. So let us try to understand what is inertia. Inertia is a natural tendency of a body to remain in its current state of rest or current state of uniform motion along a straight line. Means a body can have two states. Either the body can be at rest, means it can have a state of rest, or a body can have a state of uniform motion. So there is a natural tendency in the body to remain in its current state. If the current state is a state of rest, the body wants to be at rest. If the current state is a state of uniform motion, then the body wants to be in motion along a straight line. So for an example, if you keep your book on the surface of your study table, the book remains at its own position. There is no change in position. The book doesn't move on its own until you apply some force. So there is a tendency in that book to be or to remain in its current state of rest. Similarly, if there is a simple pendulum and suppose it is oscillating and there is no retarding force, there is no restriction, there is no friction, and in that situation it always like to be in its current state of uniform motion. So this tendency is referred to as, this tendency is known as inertia of body. So we can define inertia in different ways, and here is the definition: the inherent property of a body by virtue of which the body cannot change its state of rest or of uniform motion along a straight line is known as inertia. So you can define inertia like this. Why I have written like this, I will explain you. So this portion is common for the definition of inertia, for the definition of inertia of rest, another type of inertia, and for the definition of inertia of motion, for the definition of inertia of direction. So this block is common for 1, 2, 3 and 4 definitions. So let me start again. The inherent property of a body by virtue of which the body cannot change its, now come to this part, cannot change its state of rest or of uniform motion along a straight line is known as inertia. So if you have to define inertia, this is the definition, this portion, then this one. Now there are different types of inertia: inertia of rest, inertia of motion, inertia of direction. How can we define these terms? So suppose you want to define inertia of rest. So again, this portion will be common: the inherent property of a body by virtue of which the body cannot change its state of rest is known as inertia of rest. And if you want to define inertia of motion, then again you will start from this point: the inherent property of a body by virtue of which the body cannot change its state of uniform motion is known as inertia of motion. There is another type of inertia, that is inertia of direction. So how to define inertia of direction? Again, you should start from this point: the inherent property of a body by virtue of which the body cannot change its direction of motion is known as inertia of direction. So this way you can keep this block as common and you can continue like this. You can define inertia, you can you can define inertia of rest, you can define inertia of motion, you can define inertia of direction. So for an example, inertia of rest, a book is lying on the table in a state of rest, and the book will like to be in that current state of rest. It cannot change its current state of rest. So that property is known as inertia of rest. So this will be an example of inertia of rest. For inertia of motion, for an example, if there is a running car and it will like to have that uniform motion in a straight line unless until a certain external agent works to change its current state of motion. Obviously we have to apply brake, or if we want to change the direction we have to turn the steering. So before doing that, the car will like to have its current state of uniform motion. So in that case we can say the body is having inertia of motion. For an example, this type direction of motion is known as inertia of direction. So how to identify inertia of direction? Suppose here is a stone, and this is the stone and tied with a thread, and we are this stone is rotating on a circular path, and suppose all of a sudden at this point this thread is broken or cut, then the path of a stone would be like this. A stone will go tangentially. What does it mean? At this point the direction of motion is along the tangent, and if there is no compelling force, means if we cut this thread or if the thread is broken, then it goes like that. This means it has a tendency to have its current state of uniform motion along a straight line, means it cannot change its direction of motion on its own. So this is an example of inertia of direction. So you can easily identify inertia of rest, inertia of motion, inertia of direction. For an example, if you switch on your fan starts rotating due to electrical energy, and it gains a uniform speed, so it starts rotating with uniform speed, and then if you switch it off, means supply of current is stopped, and you must have seen, or you can watch it, that even after switching off the fan, it rotates for some time. So what does it mean? It means that it has a tendency to be in its current state of uniform motion. So again there is air friction and ultimately it stops, but that tendency is evident, visible, and you can see it, and that explains inertia of motion. So wherever you find different situations, you can easily identify whether the body is inertia of rest, whether the body is in having inertia of motion, whether the body is having inertia of direction. Now we are coming to another part of this inertia. We have defined it. Now let us understand factor on which inertia depends. So what is the factor on which inertia depends? Only one factor is there, and I am writing it here. Inertia is directly proportional to mass. So mass is the factor on which inertia depends. It is directly proportional, meaning must be clear to you. What does it mean, directly proportional? This means that if mass is increased, then inertia also increases. If mass is decreased, then inertia also decreases. So always remember it that there is only one factor, and that factor is mass on which inertia depends. For an example, a heavy truck has greater mass, and compared to a light vehicle, it will have greater inertia. Why? Because of greater mass. So this depends upon mass. And now, after discussing about inertia, we are coming to another topic, and that topic is momentum. So this is also important topic. And before starting this topic, let me remind you about different conceptual questions when you will have to answer in examinations. And for an example, one important question is asked generally, that when a bus starts suddenly or stops suddenly, then passengers lean forward or backward. In case when a bus starts all of a sudden, then passengers lean backward. When a bus stops suddenly after applying brake by the driver, then passengers lean forward. You also might have experienced this thing if you might have traveled in a bus or in a train. So why does it happen? Again, inertia is behind this phenomenon also. And let me explain this thing so that you understand and you can write the answer of conceptual questions. Suppose a passenger is sitting in a bus, and the bus is moving with uniform motion, and all of a sudden, suppose the driver applies brake, then bus stops, and the seat is attached with the bus, then the seat also stops. What happens to passenger? Passenger is there on the seat, so the lower portion of his body is in direct contact with the seat. Therefore, the lower portion of the body also stops. But what happens to the upper portion of the body of the passenger? That upper portion of the body of the passenger was in uniform motion, and because of inertia, means tendency to remain in its current state, still it has a tendency to be in uniform motion. So the lower part has stopped, but upper part of the body tends to move forward, and therefore the passenger leans forward. So inertia plays important role in different walks of life, and you will be getting notes related with this topic to solve different conceptual questions and other features. And now we are coming to this topic, momentum. So momentum, we symbolize it by T, and we have to define momentum, and we have to identify the different factors of momentum, and then we shall be getting a formula, and we can apply that formula to calculate momentum. So let us try to understand momentum. So let us first define it. How to define momentum? The total quantity of motion contained in a body is known as momentum of the body. So pay your attention over here. The total quantity of motion contained in a body is known as momentum of the body. So it refers to total quantity of motion. If a body is moving, what is the total quantity of motion present in that body is given by momentum. So we can define momentum, and we can add one more line. It is measured by the product of mass and velocity. Product of mass and velocity. So there are two factors. First is mass and the second is velocity. If we symbolize this momentum by the letter P, so this P will be equal to, it is measured by the product of mass and velocity, means mass multiplied by velocity. So this will be the formula to calculate momentum. So momentum is mass multiplied by velocity. Now based on this expression, we can find unit of momentum. So I hope this definition is clear. The total quantity of motion contained in a body is known as momentum of the body. It is measured by the product of mass and velocity. P equal to mv. You got one formula, and based on this expression, P equal to mv, I hope you understand it. We can find unit. Mass is measured in kilogram, so that is kg, and velocity is measured in meter per second. So kilogram meter per second is unit of momentum. And about velocity you must be aware in your previous classes, but let me brief you once again. If a body is at certain position x1 and it moves and it acquires, it reaches at this position x2, then this is change in position. Change in position, and this is denoted by this letter delta. Delta means change. So change in position is delta x. So suppose this display, and this is known as displacement. So if displacement is some meters, we can define velocity as this delta x by delta t, or in simple form you can have this v equal to x by t, means displacement by time is velocity. So and this velocity is measured, the unit of velocity, displacement is meter, time is second, so meter per second. So meter per second and kilogram for mass, and this is unit of momentum. What about the factors? Factors are obviously this momentum is directly proportional to mass, and it is again directly proportional to velocity. Rest of the things we shall continue further in other video sessions, and till then thank you, bye.